Tipping at a buffet, we are trying to figure out if customers who stay longer give larger tips. So the explanatory variable X is the time at the table in minutes. The response variable is tip in dollars. So what do you think? You did a scatter plot. Describe what the graph tells you about the relationship between the two variables. What do you have for that? What does it tell you? When you're describing a relationship, remember DOFs. Direction, right? Direction, form, strength, outliers. So, what do you think? Was it, yeah?
I thought it was generally positive, weak correlated.
It's positive, weak.
But it's pretty weak, and then like maybe one outlier.
Awesome. So, there is something you might say there is a weak positive linear association between length of stay and tip amount. So go ahead and check what you got. You could say people who stay longer tend to give larger tips. Okay, so B. B, what is the equation of the least squared regression line? What did you guys get for the least squared regression line? What'd you get? Y hat equals 0.03x. Good. Plus 4.5. Okay, so you should have pulled this out of the data, or you could generate it yourself. You need to explain what each variable stands for. So be sure you use y hat for predicted. Be sure you use y hat for predicted tip amount, and then x is the length of stay in minutes. And then for part C, interpret the slope and y-intercept in context. So the slope should be for each additional minute that a party stays at the buffet, there's a predicted increase. Don't say just increase, predicted increase of 3 cents. Very important you use that word. And then the y-intercept tells you that a party who stays for 0 minutes would leave a $4.53 tip, which makes no sense, right? Because that means they really didn't even eat there at all. They probably left right away, and they're probably not going to leave a tip. So that extrapolation is not really useful. Okay, so now we're going to, the question we want to answer, Charlotte's question was, do customers who stay longer at buffets give larger tips? So we want to try to figure out what the slope of the population regression line would be using our sample. And our sample, what was the size of our sample? Okay, so our sample size is 12. So we want to try to figure out what the actual population regression line is using our sample. Okay, so your state would be, you still want to define a variable. Beta is the slope. That's what we're looking for, the slope of the population regression line, least squared regression line. H naught is that the slope is 0. So there is no correlation between x and y if the slope is 0. And then our alternative hypothesis is that the slope is greater than 0. So that's our state, and then our plan. So the name of our test, we're going to perform a t-test for slope. That's the name of the test, a t-test for slope at a significance level of 5%. If our 5 conditions are met. So let's talk about those. The linear condition, is that met? Yeah, we looked at the scatter plot. It shows a linear relationship. Independent condition, we're not going to worry so much about, but we would assume that one person's tip amount is not affecting the other table's tip amount. The normal condition, you could satisfy, you could make a histogram of the residuals, or you can show the normal probability plot is linear. So we did that. So your residuals should follow an approximately normal distribution. Most of them should be at, most of your residuals should be 0, right? Because that means they're on the line. But then some of them will be above and some of them will be below. And then the equal variance, if you look at your scatter plot for each, if we go back and look at our residuals, the variability in y for each x is about the same, so that the equal variance condition is met. And then the random, we picked tables at random. So we've met those. So here we go. We're going to, now we don't actually have to do the computation because we're looking at output. And likely your last question on your free response will be this. You'll be given the output and asked to interpret. So from the computer output, our test statistic, if you go back and look, t is 1.23. We're given t and we're given a p-value. So let's find those. 1.23 is right here, 1.23 and 0.247 for the probability of getting this. So your test statistic t is right there, and you want to look for the one by the slope. When it says constant, that's your y-intercept, and the other one is going to be your slope. So you're given t and p. The thing you have to be careful about, and in your assignments as well, is that the p-value given there is for a two-sided test. And we only want to know if the slope is greater than 0, not if the slope is greater than or less than 0. So you're only going to use, you're going to divide that by 2. So you'll take that p-value and divide by 2. And then since our p-value, so there's a 12% chance of getting the outcome that we did. If the slope were actually 0, there's a 12% chance of getting the output that we did. That's likely. That's likely to happen. So since our p-value is greater than 0.05, we fail to reject H0, and we do not have convincing evidence that people who stay longer leave bigger tips.